NIC, Nick. Nick and then some numbers.
So maybe this is even different person. So
yeah. But what it does is you flash that ROM, and you've got the SerialICE itself. The ROM part, it runs on a key-config kind of system. It's not coreboot itself, but has a coreboot-like directory system. Minich, you may know the guy. He's pretty big in this area. He was working on orboot for the AMD machines, but not anymore. Yeah, exactly. It's pretty cool. I'll tell you about that in a little bit more, Al. He was working on some Rome machine, and he had wrote a patch that integrates SerialICE into coreboot itself, and that's what I'm using currently. But it wasn't accepted into upstream coreboot. But it's a very easy patch to slip into any project just to use it, even if it's not really part of coreboot per se. So, yeah. So what it does is it runs the normal vendor BIOS from, in the QEMU side, and it logs all attempts at modifying hardware registers, IO, memory, MMIO, whatever. And then if it tries to do that, it sends it down a serial port to that special ROM, and that ROM will, fiddle the hardware bits to make it do whatever the QEMU side is doing. And, that's really useful because, you can just basically log everything that the hardware is trying to have done to it. But it's also a little bit arcane because, like, if you go down the first bit, there's like a lot of stuff that's like, right, you'll see a lot of in-B and out-B, and if you don't know like the IO ports and stuff, that will make no sense. I currently have in this demo some parts of the decoding disabled because it clobbers something that I worked on. But it was letting me see, like, hey, it's probing this register. Oh, hey, this is how they keep the computer from turning itself off because this is a quote unquote gaming desktop and it's got RGB. And it turns out if you don't initialize the RGB controller on this thing properly, it reboots the whole system in like 10, 15 seconds every time. That was a fun figure out.
This is very fun figure. Like I know that you don't have time for like write up about that, but this is crazy. This is like this madness.
it honestly is, because like I got the board view. I can share my screen and show you, but like let me see. Window, open board view, share. Yeah.
Yeah, quality is not that crazy.
This little guy right here is an 8051, I think they call it, from Nuvatone. And it's got some firmware.
8051 is like a general, very old chip that everyone implements their own.
But it's hooked up to the reset lines and such, so it can turn off the computer. So you got the power off. Let's see which one of these is it. Yeah. Okay, it's not taking a direct line. Yeah.
Shall I ask how you get that one, or I should not ask that?
I mean, this one, friend on IRC pointed me at a Indian laptop fixing forum.
Okay.
You know the ones.
Yeah.
It cost me like $5, so who cares?
Yeah, paywall $5. Yep, I know that one.
You know the ones.
Yep.
But and that's how I figured it out, because Green here on Dasharo, the normal place, not Jitsi, he sent me his old LA 2016 logic analyzer, and that's how I was able actually to figure out why the machine was shutting off, because I realized that this was hooked up to both the I2C bus and the power line. So I'm like, well, let's just log it, log the I2C bus when it's powering up with the normal firmware. And, I snatched the packets, and it's like 4 bytes. And then now the computer doesn't turn off anymore. Yay. And now I can actually make progress. It is handy, though, because, like, I know where I can, like, tap in and get some signals and things of that nature.
But on the other side, like, anyone had idea why this weird, like, why this weird kind of situation where RGB controller kind of blocks booting or
Poor design.
Yeah, I mean, like, I have absolutely no
poor?
idea
This is
what.
like where this is like gentle words. Like this is like
Yeah, I have no idea why they would
It
do
actually
that.
could be used like a vulnerability, like hooking up like some stuff that, for example, like shorts up your RGB outputs, and for example, I don't know, burns your chip literally and like disables your booting process. Like that would be fun.
It would be horrific. So before I got our Minich's coreboot SerialICE patch thing going, what I actually was doing was I actually took a Raspberry Pi Pico and wrote a tiny little firmware for it that all it does is spit out the I2C things that it's expecting. So I would turn on the computer with SerialICE, and because it wasn't able to initialize the hardware itself and prevent itself from turning off, I would just plug and unplug that Raspberry Pi Pico a couple times and hope it didn't turn off. And if it didn't turn off, then I'd go on with myself.
Mm-hmm. So
But
Hannes, like if I recall correctly, like professionally, you're not doing this. Like you are not.
oh
doing
no, I'm just a guy.
Yeah, but you know, with that knowledge, like with this kind of level, like you can easily apply for, you know, for some position if you care about that. If you don't want to destroy your hobby.
There is that, and honestly, my working and living situations is a little bit weird, and I don't want to get into it here. But I'm
Okay.
kind of happy with where I am, honestly.
Sure. I'm just saying, because you're doing this, like, for if you're doing this for so long time, you essentially trained. You are like, I'm amazed because like when we talk, I guess like last quarter or even either, it was like, maybe this, maybe that, maybe this board, maybe that board, and right now like you are essentially like moving forward with so weird stuff, so cool stuff that it's worth, you know, listening and worth talking about.
Oh yeah,
And definitely good knowledge, like very good experience.
it's very fun, if nothing else.
Okay.
But you know, SerialICE has if y'all know SigRock, it's kind of like protocol decoders, I guess you could say.
Yeah.
Because SerialICE, when it logs in the rawest form. So just, you know, out B, in B, write mem, write L, read L, you know, just as raw as possible. Read CPU ID, read MSR, whatever. It doesn't actually tell you what it is. So you write filters in Lua, which I do not speak natively, to decode that output. Now they provide you with a large number of, you know, how do you say, pre-written ones that are pretty generic, you know, like Super IO based stuff, messing around with PCI config space via the CF8 register, I think. Whatever. You know what I'm talking about. So I had to figure out a few things because yeah, but does it speak the specific subset of Lua that SerialICE uses?
I don't know. Like, but you know, like, you always can try accelerate. Of course, like it depends if this will cost more time to explain it, what you want to do, or it's just it depends what you try to do. What was your task? What was your goal? And if it was easier by just like trying to feed it with that information, feed the AI, or look the forums, look the Stack Overflow, or just like have good support from someone who knows that already. Yeah.
Yeah, I mean, like I get how Lua works. Is a little weird because, you know, it's a programming language. I mean, it starts counting at 1. What's up with that? That's weird. But
That's LaTeX stuff.
Yeah, that's weird. But you know, I knew what I wanted to do. I just needed to learn the vocabulary and grammar to say it in Lua. And the reason why I had to write another filter aside from the other ones is, one, SerialICE as it currently stands is currently heavily teched out to Intel stuff. It doesn't really have much AMD specific support, let alone Ryzen specific support. So like I could see a lot of MMIO operations that look like they're probably messing with the data fabric and things of that nature. because like, you know, turn a PCI BDF into MIO address and it's the right spot. So I guess that's what it is.
Yeah, I
And
guess like what my question would be at this point is like, what does it mean? SerialICE knows better Intel. So is there a easy way to tell SerialICE to recognize certain pattern of, I don't know, MMIO, to know how to name it, or like how this help you? How SerialICE knows about that, and how this help?
well, like I said, you write. They call them filters. They're basically protocol decoders. And when you run the replaying software, because it comes with the replayer so that you can, you know, play back and look at, adjust the filters, play back, look at, whatever. It comes with that. And how do you say? It comes with that. And the first thing it does is it at the very beginning of the process, it records a little bit of information about the hardware that you use to record. So, you know, the make, model, yada, yada. And from that, it can determine which Lua files it needs to load. It'll try to find a Lua file in the mainboard steer, load that, evaluate it, and use that on top of all the standard filters. SerialICE comes
but
with...
how does Lua filter help? Like, does it like replace something and make it human readable, or like what?
It does that, and also sometimes you really do not want certain hardware operations going from the QEMU instance to the real hardware. Like that was an issue I had early on. Was the firmware itself in QEMU was attempting to configure the serial port, but the communication between the hardware and the emulated ROM is over the serial port. So if you fiddle with the serial port, the link dies. So that's one thing you can do with the filters. You can explicitly filter things. Like, I really do not want you to actually send this byte to the Super IO and turn on this thing, because that will destroy the whole process. So you fake actions, you modify actions.
Because essentially you will... Yeah, I understand, because essentially you will have to have real hardware, real controller, which respond with some register status to that action, and you don't have that, so essentially you will very quickly stop the booting process, But but continuing this, like faking this, like essentially this filter like fakes the situation, like help in faking that you are not, that you are on real hardware, like,
well,
but you are not on real hardware,
It's the ROM is executing in the QEMU, but it is forwarding all unhandled IO and all IO that is allowed to be to the actual hardware. So if you don't have a filter for something, everything that is happening on that something goes to the real hardware. It's only with a filter that you can discriminate and choose that, okay, I'm okay with this going to the real hardware. Because I know it won't break the setup. It won't, you know, halt, catch fire on me. Also with filters, you could do useful things like you can lie to the firmware and tell the firmware, oh, this is only a single core, single thread SKUs. Don't even bother trying to wake up those other ones, guys, because that might confuse things, you know? So
yeah.
I think I might be having an issue with relation to that, but I don't know yet, because like right now, my chief difficulty is that SerialICE works for the most part, and it configures a lot of things. I see it happening, but then it gets to a certain point where it gets in a polling loop, and I got to figure out how to get around that somehow. But yeah, the way it knows which filter to load is...
Let's try to wrap up how this whole process help in kind of open source firmware development.
Well, in this case, and probably in Intel as well, but I don't have an Intel machine I can run SerialICE on the offhand. You can run it with modified firmware, right? And that was one of the first things that I tinkered with on this machine. Is I was disassembling, and if you go in the ASCII cast to 618 time, you'll notice a very large wall of text.
Okay.
And one of the first things I was trying with this thing is I was disassembling the firmware, into its PEI and DXE modules and such, and then loading them up in Ghidra and hurting my brain a bit. But I noticed there was a lot of printf-looking strings in it. And what I ended up doing with that is I, dug down into it, and it turns out all those is a search for a particular PPI, which is a protocol in UEFI. And, it has a GUID. And if it finds it, it calls a function from it. And I'm like, well, why can't I do that? So I hacked together.
This is.
Go ahead.
This is exactly PPI is a PAIM to PAIM interface.
Yeah.
So it's like a PEI stage
exactly.
before DXE. This is like protocols, because protocols are for DXE, and PEI got PEI module to PEI module interface. So this is how the PEI modules talk with each other.
Right. I mean, like, I might not know the exact terminology properly, but thankfully, because the way UEFI is put together, the binaries are very structured, and you can usually spot some data structures and figure them out. And there's a couple of projects that are really nice on that. But I hacked together a very small PEI module that implements that PPI, that PAIM, that PPI, whatever. And I inserted it into the firmware, and I flashed it on real hardware, and it worked. And it turns out, like I said, if you go to 618 or so, I could do this on SerialICE as well, and I could get all this debug information out of it.
Like, just a second. What doesn't mean you hacked? Like, what precisely you did?
I took the UUID that I was given, and I wrote a PEI module that uses that UUID, that GUID, and fiddled around until I got it to work. And then I used UEFI tool. You may be aware of it.
Yeah.
To insert the module into it, and then I modified the a priori pi file, which is like a load me first.
That's crazy. That's crazy like shit. So you essentially wrote a PEI module. So PIM, PAIM to PAIM, PPI are protocols where PEI modules talk with each other. So you write PEI module. How you write it? Like, did you take like sample PEI module from UEFI if you're EDK2 and just like write it and compile it, or how you did it?
I was looking at the source level debugging package.
Oh yeah.
And I was going to see about getting that to work, but then like I said, I was digging around and I found that particular thing. I'm like, that might be really useful. Let me try to make that work. So I followed a lot of I bodged together a lot of code that was in that particular module.
So how much time it took? Like, how much time it took to?
That was at least 2 weeks of fiddling.
Okay. Like total hours? Like, it's like I guess like you're doing this after hours, or how this works?
I usually go real hard on this stuff, like maybe like for 2 hours a day.
Okay.
Because like there was a lot of issues involved, because like the PEI phase is really, really sensitive, and like because of the fact that the initial code load on this particular Ryzen board is, I've only got 3 megabytes of space, and it was already jam packed. I had to I was using SerialICE a little bit at that time, and if you look in the column between the brackets, those the second one, FF whatever, that maps basically directly to the address on the flash chip itself. So I was able to figure out what modules were actually being used, which ones were not being used, and actually excised a few modules to make room.
Okay.
And yada yada.
Yeah.
But yeah, that was that. And like I said, apparently it works in SerialICE itself, which is great.
Okay, but so you managed to do that. Like, this is great achievement, but still, the question is like, how this make us closer to open source firmware?
Oh well, somewhere else in this particular video, but it has a section where it spits out what in how do you call it in Ryzen and coreboot terminology they call port descriptors. Now, it doesn't help me yet because apparently there's something going on here that I need to fiddle with more. But in theory, if you can pull out the port descriptors in that manner, you should be able to use it on porting your new one, because like it tells you like, you know, oh, we're going to turn on this GPIO. It gives us a lot of debug information. And I don't know that every AMD Ryzen firmware or hardware or any of it is going to have this kind of information available even with this kind of a modification. But for the ones that are able to accept a modification of this variety and it'll work and you can pull this information out, you can use as a starting point for putting together the board port, you know? And I still have issues going through with that, but right now the only thing that's really holding me back is these platform descriptors, because like I can actually boot coreboot. It runs through FSPM, FSPS. I had to modify the SFP, the memory blob a little bit to make it work, but that's besides the point. And it'll load a payload, and it'll even try to boot Linux. But after that, I'm kind of kerfuffled.
But like, is it problem of Linux? Is it problem of initialization of the system?
I'm not sure, honestly, because the builds that they give you, they do not talk. The FSP builds that you get from whatever it is, it doesn't talk. That right there is... Oh, hang on. Yeah, there we go. There we go.
So I guess like we should try also to address void concern. What is this hardware detection tool? You were able to run hardware detection tool?
Yeah, it's got. I was, like I said, a lot of interesting. I could try that.
So this is on real hardware. This is coreboot on real hardware.
The second one is real hardware. Yes, that is absolutely real hardware.
It's very good. That's congratulations. Like that's incredible achievement. Like damn, and it's on Ryzen 3200. Yeah.
Yeah, 3200 on that ASRock board.
Is this code already somewhere in?
Oh yeah. Give me one sec. I got it on my GitHub, and it is on the Garrett, but I ain't getting any action yet. But I've been talking with people about things.
So I guess like we should like try to wrap up. But I guess like there is a lot of question, and I'm like mostly concerned about void disconnection. So I guess like we should address that, and then we can go. We can try to get back on track with like where's coreboot on all this, and so void like I'm trying to understand like how we can help you to understand what's going on here, because I see that Hypnotic tried to explain. It's okay. I don't need to. Okay, that's fine. Okay.
If you ever want to talk void, we could talk anytime.
So he's got problems with this audio stuff. And
yeah, I remember. You thought he was over Tor.
Yeah. But
I thought he was over Tor.
I'm sorry.
Anyway,
no.
He mentioned that earlier. But anyway, so Hanetzer, like, so how's things with coreboot? Like, so what's the major like blocker? You're saying this Linux not booting or something?
Well, I'm not sure if it's a killer, because this Linux is booting off of a USB stick. As far as hardware that works on this thing right now, that I know to work, there's a few USB ports that work, and and theoretically maybe hang on. There's a few USB ports that work. Obviously, the serial port works because that's bog standard. And if your serial port doesn't work, what the hell are you doing? But I boot it from the USB. I've tried it with both an installable, an ISO on USB type thing, or also with the an actually installed system. Neither of them actually work. So I'm not really sure here what is failing.
So it's like a malfunction of the of the initialization of the USB controller?
I don't know, honestly, but I think it might have to do with those platform descriptors or port descriptors, because right now my major issue is like if I send any port descriptors from coreboot into the FSPS binary,
Mhm.
the whole thing halts.
Hmm.
And it doesn't give me any feedback when it does.
Mm.
So that's the big thing, because if you don't know the platform descriptors, they're just basically saying, hey, I've got a 8x PCIe port here. Oh, hey, I got a SATA controller here. You know, a lot of the really important things need a platform descriptor to work. And then, you know, there's a few ports and things of that nature that are underneath the
Why
the
you cannot
extra.
catch it? Like why you cannot catch this as exactly this piece from the SerialICE?
Well, that's why I was saying it catches itself in a loop. And I did catch that information. If you watch it through, you'll see a section where it says sending this platform descriptor to the you know, to the SMN or the SMU. I forget exactly what it says, but you'll see it say that, and then it'll show you a hex dump of the platform descriptor. And before that, it gives you a little description that's it tells you what's going on.
And did you try to send the same?
I did, and like I said, if I send anything, it doesn't work.
Okay. So maybe
So
there
I
is
think it
some
might be
previous action that makes this possible, even. Yeah.
Yeah, I mean, like I've been digging around in the FSPs modules, because the FSPs they're UEFI file systems too, so they've got the same structure, they've got the same
Yeah.
ability to be, to figure it out from that.
Mhm.
But it's frustrating, but it's fun. No, actually, they are not encrypted at all. They are just plain old, binaries inside of FFS.
Yeah, with probably with header saying do not reverse that.
Yeah, I don't give a shit.
That's fine, but
That's probably one reason why I'd probably never go into this as a for a profession, because then things.
Yeah, legal.
Yeah, but I'm just a person. What are you gonna do?
Yeah, true. Unless you will make money, like huge money on that, that's then they will pay for you.
Right. We'll see.
So you plan to make money on that?
Hey, you never know. I don't know what is gonna. I mean, like it would be nice. I'm not gonna turn down a grant or anything of that nature.
Mhm.
But like I'm not doing it for the money. It would just be nice sometimes.
Sure.
Well, yeah. I mean, Void. Yes and no. I mean, like the FSP, it's just x86 code, and Ghidra handles that lovely. And there are a number of Ghidra extensions that are specifically tailored for working with EFI based binaries. So when you use those extensions, it knows certain kinds of EFI types. It knows what a GUID is. It knows what a PPI is. And it can find some of those. Some of them you just got to have a little bit of a intuition and you looking at it for a while. Because like now, I just spot the shit. Because like there's like certain structures that, like we were talking about the PPIs. The PPI is a certain magic set of magic numbers and bit fields basically. Then it's a pointer to a GUID. Then it's a pointer to a function usually. Sometimes it's just a pointer to data. Once you know what you're looking for, it's there. And like I said, it's very structured. I have no idea about machine learning, bro. I know it makes funny pictures. But yeah, I mean, like that really about covers it up. But like, even once I get this particular issue figured out, as far as like getting the PCI stuff running and maybe figuring out how to make the USB boot, I was thinking about maybe trying a Linux boot payload, because then it would like take another element of confusion out of it. Because like I'd like to get some kind of shell into the system under my firmware so I know what's going on, But aside from that, there's another difficulty, but I think that's not going to be as hard as one might expect. Is that the chipset on these devices? They also use firmware. But it turns out that a friend of mine, Cyrozap, I think I'm saying that right, he's working on an as-media reverse engineering project, and it turns out the firmware that these things load into the chipset is exactly the same format and file, yada yada. And the Asahi Linux folks, they figured out how to load those properly, so we could probably just, crib that code from them once we get to that point. But anyway, that's about it for me, I guess.
Yeah, I guess I love it. Like I love it. This is like great. This is like great testimony. Like.
Yes, that is an open source moment, Void.
So the church of open source firmware needs testimonials, and your testimonial was really great. And what I can say, like this story is, you should have a write up. I know that you probably.
I'm working on one, but like, I'm not a writer. I'm not a talker. I just like to tinker, bro.
Yeah, I understand. Like this is authentic. Like I understand that. It's hard. It's probably very hard, but I'm just saying you what will bring like a lot of value to the world. Yeah, and write up about this would bring a lot of value to the world, definitely. On the other side, the problem is, I guess, to someone follow your path and essentially, because like you just I guess talk with various people, get the advices, and do this travel, do this like journey of going from this to that, from that to that, from that to that, and that journey is, and the fact that you were so kind of, I don't want to say stubborn or I don't know, like it so much, the experience that you get through that is very exciting. But on the other side, the question is like, if there will be another person, and I'm pretty sure there are many other people who may even step on that journey, on that path, on that road, and they didn't get through because they were not so convinced, or maybe they hit the wall at some point, and you already solved some problem, which help move one step further.
Yeah. I mean, like, there are a lot, like I said, the RGB controller killing the thing. That's
yeah. You never know what killing what's going on with it.
It boggled my mind when it was figured out.
Yeah. So that's really great. I wondering where this will go, and I'm very happy, Hanetzer, you are part of Dasharo community, because like we also need people that saying plainly, like, I don't want to deal with that professionally. I just have fun, and that's good for me. I like at some point, this is maybe a little bit going into philosophical discussion, but I made that switch, and sometimes I have feeling of regret. Yeah, there was so much fun, and now there is like you are forced to do this and that and that and that.
Mm-hmm.
But on the other side, the question is why you're doing these things, and I guess like your motivation aligns with what I think with my motivation also, like, or my motivation is aligned with your motivation at least a little bit, because you're looking for this transparency for what's going on behind the scene and why, and loving discovering the how computers work, and that's exactly what 3M the and Dasharo is about.
Yep.
Yeah. So
it's been a fun one, that's for sure.
Yeah. So thank you very much for that. And I guess like if there are any questions regarding the SerialICE or
let me go ahead and share also the repo that I have that shows the SerialICE stuff that I threw together to make this work.
Mm-hmm.
Hang on.
So please note that the Jitsi chat is not persistent. So whatever you put there is like it's better to send to Matrix. Like Matrix will
Right.
will
Yeah,
keep
put
the
it in the
information.
general.
Yeah. I'm doing it.
Was my lagging or no?
Yeah, you lagging, like you just cutting off like between the words. I would say.
Yeah, it's like someone was flipping the mute switch every third word or so.
Yeah.
Just on, off, on, off, on, off.
I can certainly support that. I forgot the correct term. I'm trying to translate right now between languages. That's what happens when you're
1, 2,
bilingual.
3. I'm
No, you're not on.
It sounded like you're announcing that you're going to mute yourself.
Anyway, I'll be right back.
Sure. I guess like I will try to reconnect because I'm still on my LTE. I will try to reconnect from my network and see if anything is better than it was before.
Just one question. No, I mean for you about your connection.
Yeah.
Do you use a third-party DNS provider?
No. Okay, third party. What you mean? Third party. Third party to whom?
To your ISP?
I guess. Let me.
I
check
mean,
my
do you
router.
just
I
leave
guess like my
the
router
DNS?
picking up the.
I mean, do you just leave the DNS?
Yeah,
in
I
the
leave the.
DNS settings. You just leave it as default or blank or whatever it's called.
Yeah, I. So.
Okay, so there's no
So what I have, like
promises
we
that
already
this will
discussed. I
help.
have this.
There's no promises that this will help, but perhaps putting in Quad 9 or Cloudflare, if there's DNS addresses, might help a bit. It helps me.
Okay.
At least I believe it helps me.
Okay. So I have to see what's going on with this problem. So definitely switching to LTE on my. So I just like run LTE hotspot on Graphene OS on my Pixel, and it worked. So you see that I'm not cutting out like it was before, and I was able to give the roadmap presentation. But on the other side, I'm on 600 meg symmetrical fiber, so I should not have this kind of shitty situation. Yeah. So what I will do right now, I will switch back to the.
That's why I mentioned the DNS providers, because it could be due to latency, not due to bandwidth.
So I will tell you
Although
like
there
this.
could
I will
also
right now.
be an issue with one of the servers in between. Maybe some server on the way is failing. I don't know.
So let's do live testing. I will just switch to the to my home network, home Wi-Fi, which going through my firewall, which going to this fiber, and we will see what will happen. But the difference is that before I was on CubesOS and I was on the using Cubes Video Companion, which is kind of very heavy because it's essentially filtering the video and video stuff. Yeah, Cubes. But I'm on Dasharo. I'm on MSI. So this is like 12th generation CPU. I have 128 gigs of memory on my workstation. So, and I had no issue during Dasharo user group 2. But after that, I did the updates, and I wonder if this is like.
Yeah, I remember that. I was almost in awe in how stable your connection was.
Yeah,
looking at the from the stats.
So you see, so something is wrong. So either my ISP. So I noticed these errors before. That's why I asked you about this continuous bandwidth measurement. And to be honest, I tried to look for OpenSense if there is some solution for that, but I didn't found. So my point was like this. So my ISP giving me some SLA. So I will check them. But the question is like how to deliver those proofs. So shall I like 4 a.m. run the bandwidth test every day for whole month and just show them that, damn, like even like everyone's sleeping around, I'm not getting like close to what I'm paying for. Yeah. So the question is how to prove that. But just give me a second. I will switch the networks.
No problem. I have a few tips in that area how to check the network connection from my experience.
Yeah, we can talk about that in a second.
This also touches on OpenWRT. Lenovo laptops generally have, at least from the time period of my laptop, generally have numlock on enabled when you turn it off, and they give you no option by default to change that. That's what was one of the primary reasons why I wanted to unlock the firmware. Now it finally it's disabled when I turn it on. Sorry, I'm sorry.
Can you guys
Hello?
hear me?
Hello?
Hello.
Void, you're lagging. Like you're lagging as hell.
I'm.
Yeah, but
Hello?
Yeah, you're really cutting out.
So
Okay.
Muriel.
Yes.
So you see, I switch it but my bandwidth still jumping. Like I can disable camera, but the bandwidth's like jumping. Like downstream I have 31 kilobits per second,
for me,
and
it's not
upstream I have
showing
3
bitrate at
megs.
all. Yeah, for me, it's not showing bitrate at all. I think that last time I was able to see anything because we were on the main GTC servers rather than the 3MDeb servers, because I'm guessing that it's set only you could see that data.
Okay, but anyway, so right now like it's okay, but when like if I let's say I enable camera.
I personally, this is something that I've been telling people around, at least in my country, that in many cases that at least in the US, from what I understand, it's even worse. That regarding the behavior of the internet providers, of the ISPs, that in many cases you can't fully test things without using as much hardware as possible that you own, and preferably that you also replace the firmware with, for example, OpenWRT or something. But really, the important thing isn't that you're running a different firmware here, but that you have access to the actual information of what's going on. So if it's on DSL, regarding the information regarding the communication between the DSL modem and the DSL AM. Or if it's on fiber, the information of what's going on between your transceiver and the infrastructure providers transceiver, and so on. So again, this isn't even, that's not enough, because you also need to prove that if there's no issue between you and the ISPs, the network providers, the infrastructure providers hardware, and there's no issue between them and the ISP, that's when you need to run the test that aren't as reliant on what hardware you use, and you could use it with an ISP router as well.
Yeah, I guess the point, but maybe right now it's okay. Like I'm like right now I'm on 5G Wi-Fi from my Lenovo laptop.
5G?
With the same
5
network.
gigahertz. You mean 5 gigahertz?
Yeah, 5.
Yeah, I use it.
5
I use it to. I purposefully differentiate in order to prevent confusion. I've
Yeah,
had
true.
people asking me in the past about 2.4 G cellular. Wait, what?
Yeah,
Testing. Can you guys hear me? Hello.
yeah, we hear
Ah.
you.
I can hear you.
Is it lagging or is it less lagging?
No, it's
A lot less.
Much better.
A lot less.
You're
It's
still
like
cutting out a bit, but in comparison to before, barely.
Okay,
what
something's
did
wrong
you
with
did?
the Cubes.
What you changed? What you changed?
I changed from USB microphone to Cubes to my internal microphone.
Whoa.
Something's
USB
wrong about
latency.
the interrupt latency of USB on Cubes. I tried it before.
So
so that's not interrupt latency. That is because every USB packet will be passing through QEMU on its way between the VM and the hardware.
The thing is, I passed my current presentation VM has the USB controller passed to it through hardware. Does that still have the same issue?
Could you try using a analog audio? I mean, externally by if you have a 3.5 millimeter jack.
I mean, if I do the analog audio, it's basically the same as passing my built-in mic to this VM.
But in theory, you should. There should, in theory, the 3.5 millimeter audio jack could provide slightly better audio if that's what you're looking for, even if it's not as good as a dedicated.
Moriel,
Yeah,
the problem is, I guess, with the VMs. Like it's like
that's obvious. That's obvious.
No,
that's why I was mentioning the 3.5 millimeter jack, precisely as Void said, that it would be the same as the internal audio in that regard. But the difference is what can be pushed through, because instead of having just a microphone, you have a more generalized port, although it's still dedicated to audio. And you could test different microphones to see whether one of them electrically. Sorry, Void.
Look, I've already passed the USB controller into this VM. Currently, my VM is running in HVM mode. Like, I really don't think it's a like pass through issue, because like I'm getting something wrong with the USB stack, because like for my internal laptop mic, when I pass it through like from DOM 0 to this VM, there's no lag. That's what I'm using right now. But when I'm directly, like, this VM is an HVM VM right now, and the HVM VM is the USB controllers are directly PCIe passed through into this VM. My USB mic is not passed through Cube's RPC, but it's directly connected. Even directly connected, there's like insane lag. So I'm thinking there's something wrong with the USB latency, or just how Zen processes like real-time USB.
Yeah, but the question is if this is a new thing or it is old thing. So I will do experiment. I was proving that LTE works. Now I'm proving that my Wi-Fi works, which is Wi-Fi like Debian, Wi-Fi, and fiber. And I will switch to Cubes, and we will see if I will face problems. Because if I will switch to Cubes and I will face problems, that means that it's not my connectivity, or maybe I don't know. Maybe my Ethernet is like broken.
My microphone, my USB microphone works on bare metal, no problem. There is no lag. I've used this microphone bare metal before, and there's no lag. It only happens on Cubes. No matter if I try to pass through from sys USB or directly connected to like whatever VM that's going to do.
So I have my Yeti connected to sys USB, and I have also camera, the Logitech camera connected through Cube's video companion. And yeah, that's what I'm using, but it's very heavy. Like the G streamer passing through the video stream is like very heavy stuff. So we'll see, but Void, you already have good configuration, and I'm very happy that you will be able to have your demo presentation and like tell us about the the OTP stuff. But first, I guess like we will
Okay.
have Felix in 6 minutes.
Piotr, just one thing.
Sure.
During that last sentence, you meant when you said that Wi-Fi is working, right in the middle of the sentence, it could be something that happened to me. Not that sentence, the sentence following that, your video cut out.
Okay.
It didn't cut. No, it didn't cut out, but it froze for a few seconds and then continued.
Okay. I guess like I will disable my video. Marek?
Yeah, so that video issue was probably Video Companion being too heavy, but I guess we can
I'm
do some
not at
debugging.
Video Companion right now.
Okay.
I'm on Debian right now.
Okay. I guess we can do some debugging session on Cube Summit next week. So
Yeah. But the question is if we will have hardware. So I will not bring my MSI. It's like kind of heavy.
well,
But,
I can bring one of those I have here.
yeah, I'm not sure if you should put out this. Like anyway, I'm not sure if. So the question is, what is the how to diagnose that because you have so many pieces. Like you have this Jitsi stuff, Jitsi, like what's so weird. Like the server behaved so weird for everyone today. Yeah.
Yeah, that Jitsi, I'm not sure, but
Well said, Piotr. Jit shit. You almost said that.
Okay, I'm just like I'm drinking my single malt, so like I'm starting to
Yeah,
shit.
but Jitsi, they are forcing this authentication now. I think they are facing some performance issues, like too many users or something like that.
Okay.
Because you see, it's much better on your instance, and it's
Yeah. On the other side, I completely changed my setup, so maybe that question is like if this was problem that I faced or everyone faced. Like I'm not sure, yeah, because definitely I had so many problems.
But you're still on Cubes 4.1, right?
No, I upgraded.
Oh, you are on 4.2?
Yes.
Okay.
But Marek, I don't know. Like I'm using Debian 12, yeah. So maybe this is like something not compatible.
Maybe. Okay, but I think we can look at it next week. I will.
Let's put that on schedule. Let's put that on schedule. Yeah. True.
See
Good
if
point.
sharing my screen also works. How can I do that here? Wait a second. Okay. So, can you see my slides?
I see cursor and black window. I see your cursor. So, but that's it.
Yeah, that's not much.
What format your slides are? Can you drop PDF into the chat and then we can like just, or I will share it or something like that?
Yeah, sure. I will create a PDF.
So I'm not sure if I'm a good example of sharing because I also had problems. But maybe Michał can share it or someone.
And if nothing else, we could all just read along.
Yeah. Yeah, to be honest, like Jitsi is very not friendly for us today. Either public instance, either private instance.
Yeah.
Okay. So I will just share my slides in Matrix. Is that okay?
Yeah.
Okay.
Just to vPub channel, and that's fine.
Okay.
Yeah, here it is. Okay, I can try. Maybe my sharing superpowers will work. No. I'm also doomed. Kurz. Someone can share those PDF files like with, I don't know, Firefox or whatever technology works for you. My Chrome doesn't work.
Hang on.
Moriel, like you sharing, but I don't see it. I don't see anything. I don't see the slides. But anyway, we can go like slide 1, slide 2, and that's fine. Everyone got the slides.
Yes, sure.
So let's go on, Felix.
Okay, so my talk today is about challenges with modern
Whoops, I
security
forgot to enable
mechanisms.
my microphone. Should I stop sharing or
yeah,
should I
so
continue sharing?
just,
you can stop. You can stop.
All right.
Sorry?
No, it's you probably don't hear Moriel.
I disabled my
I see
microphone,
slides.
that's all.
Yep,
Oh
that's
my
me. Hang on.
More than
Okay.
I talked and no one heard me because I forgot to
Yeah,
turn
so,
on my
I hear
microphone.
you. Void, do you hear me?
Yes, I can hear you.
Felix, you hear me, but sorry, that was Moriel.
Yeah, no, I
Void-
can hear it. I can hear
Void
it.
here,
Sorry.
I can hear you, Petrushnik.
Yeah, let's mute. Let's give Felix the stage.
So my talk today is about modern security mechanisms and which challenges they bring in terms of open source firmware. And
just a heads up.
so just a little bit about me.
I'm currently
I'm an
consulting for my
open source
parents, reading in
enthusiast.
books, so
I spend way too much time on open source projects. I'm mostly working on coreboot and things around it. But I'm also a little bit involved into NixOS and Arch Linux. Specifically, so for example, I'm packaging the coreboot toolchain for those two distros. Yeah, so why this talk? I started to think about which barriers beginners or interested people might have, and how we can simplify their start into this field. And yeah, so some barriers are mentioned here. It's, for example, closed source binaries, which are necessary for the platform initialization. They are a black box, and people are scared of them. People don't know how to debug them or to solve issues. Yeah, so it's just very hard to deal with them. Another issue is that lots of documentation is not available. So it's just available under NDA. Yeah, and another issue which this talk is about is the firmware validation, which in case of Intel and AMD is BootGuard or the PSB, the Platform Secure Boot. The good thing about firmware validation is that it's a security feature, so it's good because it prevents bad people or attackers to modify the system's firmware to do bad things and such. But it also comes with a downside because it prevents users to use their own firmware. And yeah, so it also has a negative impact on sustainability. And so the problem is vendors. It doesn't matter. It doesn't matter who of them, Lenovo, Asus, and so on. The vendors don't document on which hardware they enable their firmware validation. I don't know much about I don't know much about how AMD works or how it works for AMD, because yeah, there are not many things public available. So this talk is mostly about Intel BootGuard. Yeah, just to give a little overview how yeah, things. Well, it's a very small overview, but just to give a little overview about how things are implemented. In case of BootGuard, it comes with the management engine, and the management engine resides in the chipset. So in case of low power platforms, it's one SoC, so it's one chip which is soldered on the mainboard, but with on desktop platforms they are separated. So when you put the CPU in case of the firmware validation is enabled and you put the CPU onto another mainboard, the CPU still works, which is not the case for AMD because the platform secure boot comes with the PSP, and so PSP is the equivalent of the management engine, and the PSP resides in the CPU package. So when a vendor enables the firmware validation, the platform secure boot, then and sets diffusers, then it's impossible to reuse this CPU on another mainboard because the signature does not work on this one. Yeah, so back to the open source developers. When we want to figure out which mainboards are locked down and which are not, which possibilities do we have? The easiest one is also maybe not for everyone, not for every person, but for a beginner, the easiest solution is also the hardest one, because buying the mainboard and then modifying the firmware and trying it out, and it's kind of hard. Or yeah. Another possibility is using UFI tool. UFI tool recognizes signatures of BootGuard, and yeah, and gives some hints if BootGuard is enabled or not. But even then, it might be possible to boot another firmware even then, because BootGuard can run in different profiles. So, for example, the vendor may enable BootGuard, but the mainboard may still boot. That's one of the profiles. Another profile is that BootGuard is just enforced, and yeah, the user can't do anything. Another possibility to check is the Intel ME tool, or reading the registers manually, but also that is it might be kind of overwhelming for beginners, or for beginners, and so it's also not a proper solution. We also could use hardware vendor tools, but so in case for Intel, for example, they have some tools where you can open the firmware image, and then you can just see which BootGuard profile is enabled, and but it doesn't tell you if the fuses are set. At least in my understanding, it doesn't tell you that, and I think it also doesn't tell you if the management engine manufacturing mode is enabled or not. And I think in case of that, you can just disable BootGuard and run your own firmware. So my idea is a collective approach. I just called it BootGuard status. I started it some years ago, and it's basically just a markdown table listing different vendors and their mainboards, and and the idea is that people who found out the state, the BootGuard state of their mainboard, just document that, and and so it just gives an overview, and whoever is interested can look at this list, and they can just pick a mainboard they want to work on, and and people who are not that deep into this field or into this topic, they don't need to be afraid of buying something locked down. And so that's basically the idea, and that's it.
I guess there are questions, like Hannet said.
So, hang on, how to phrase this. So sometimes when I'm looking for information on a particular board,
I can't hear Hanetze.
You cannot hear me.
Yeah, so I hear him. So Felix, rather the problem is on your side. Can you try to just re-enter the session?
Yeah,
and
sure. Just I can just type it real quick.
Should
yeah,
I?
but it still will be problem. Like just like
okay.
reload the page, Felix. Just reload the
Okay.
page, and I guess you will get it. Yeah, let's try it. Felix, you're muted, by the way.
Okay.
Can you hear
Hannes.
me? Can you
I
hear
still
me?
can't hear Hanetzer.
Oh, okay. So maybe that's Hanetzer. Like that's the other option.
Wait. I will restart Chromium. Wait a second.
No. It's Felix.
How about
Damn.
now?
I don't know. Felix decided that this is his problem, so he restarted the Chromium.
Okay.
Can you hear me now?
Yes.
Okay.
Yeah.
So sometimes I want to look up some information on a particular board. I'll go to I forget the exact name of the website, but it's like linuxhardware.org or whatever, and it's just basically the same kind of idea as what you got here with BootGuard status, a collective approach. Do you think it might be worthwhile, because like a lot of people will just run this information on their hardware, even though they might not be interested in coreboot per se, to maybe talk with those guys to see if they can incorporate the tools that might be able to tell that, and then that way we get passive collection regardless?
Sorry, I'm not sure if I
Yeah, I'm
understood
not.
the question.
I'm also not.
Okay,
getting this.
So there's there's a tool. It's basically like it's an app image. It's a whatever. They got it in a million different forms, and it runs, LSPCI, DMI decode, sensors detect, all those goody hardware detection stuff, right? And it takes all that information, anonymizes it if need be, MAC addresses, IP addresses, things of that nature, and uploads it to an online database where you can query the database for a particular piece of hardware, and then look at that piece of hardware and see what's, whatever Linux can report. Do you think maybe it might be worthwhile to speak to the people who run that project? Like, hey, I would really love it if you added this particular form of detection into it. That way, people who are running this tool for other reasons are passively collecting the BootGuard status of their devices. Ask them to run Intel ME tool as part of their probe.
Yeah, sure. I didn't know the project before, so linuxhardware.org.
Yeah.
No, it's not.
They got an app, and it, like I said, it runs LSPCI, DMI decode, yada, and collects all that information, anonymizes it, and uploads it. So it's got all kinds of information on all kinds of hardware there.
Yeah, sure. I think that would make sense. That would be great. I actually.
You hear me right now?
Yeah.
Yes.
Yeah, you didn't heard me before. So we were in contact with Linux hardware when he noticed the Dasharo reporting in the BIOS section, and of course the database can be extended to that, but we have to work with such big. And on the other side, the question is if there is any limit on running those applications which gather this information, because you have to provide certain specific conditions, and I guess like Linux by default not booting giving the so much access that you can check the registers.
Oh, you're talking about like IO memory LX and such?
Yes.
It would be, well, even if that is the case, maybe Linux hardware people could, provide a caveat when they use the application, like, hey, this works better if you boot with this enabled.
Mm-hmm.
But
Hanetzer, that's why we're doing DTS, the Dasharo tool suite, and we kind of because we have custom baked kernel with of course some protection disabled because of the because we have to access this information, this information which is normally in every distro locket. So ideally would be if we can ask people. I understand your point. It would be easier if we can passively gather this information, but it's not that easy, and would be harder and harder, in my opinion.
Okay, it's just an idea,
Yeah. So better would be like this. like better. I don't know if it's better. It's not better because it will not gather so much results as you're saying. But the situation in which someone asking the question, like asking, is my hardware capable of being ported? And then like we're just saying like just run this, and like it magically will tell you. Because right now the problem is, Felix tried to describe this, but on the slide that the analysis of the output is too complex. So yeah, you're getting ME status register, you're getting the BootGuard status register, and so on and so on. And what? If you don't know how to interpret those numbers, then this doesn't tell you anything. And I wanted to bring Michał here, Michik. I don't know if he listen.
Yeah, I'm listening.
Yeah. So I'm just saying like the problem is not about. It's not about, we cannot gather this information. We can gather this information. There are tools for that. But the point is to represent that in a human readable way. And Felix trying to achieve that with the GitHub page where he essentially gathered this information. But the point, Felix, is exactly, I guess the problem is exactly the same like with HCL. So we gather this information, or this gathering this information is too complex. But Michał, tell me about one thing, the statuses of the registers, how hard it is to interpret that? How hard is the logic diagram of interpret that?
For the BootGuard, well, essentially, we have to consider only two cases. Before
Felix, are you attempting to talk?
Should I continue?
Felix, are you attempting to talk or?
No,
Okay.
No, sorry. Go ahead. I actually don't know that much about the BootGuard registers yet, and
yeah. So what I wanted to say is that we just need to consider two cases. Before convert BootGuard NTXT was introduced, and after, because this is where the registers got a little bit
like I want to figure
changed.
out like.
But
Hanetzer,
yeah,
Hanetzer, do you hear Michik?
No, I do not hear.
Oh damn!
Okay.
Damn. So Michik's talking and you don't hear him.
No,
Yeah, that's
I
great.
hear nothing but me and you right now.
Okay.
All right, that's also fine.
What to do with that? I don't know what to do with that. So we can try this experiment with this instance that Maciej pointed to, this Galena. It seemed to work. This is NLNet. I don't know if you know NLNet. This is NLNet instance. So those who know NLNet is like they are a very trustworthy group of open source sponsors in Europe, in Netherlands. And maybe we will solve like problem for our small group.
yeah, that would be awesome.
Yeah, let's try that. Let's try that and we will see. Minutes,
Yes.
not 1 hour. Please.
Okay, Roger. Wilco. So, this is my presentation, one-time pads and introduction and discussion of its future. Who am I? I am a very paranoid electronics hobbyist who is into privacy and anonymity, and you can contact me here on Matrix, as seen in this on this Matrix address. TLDR, what the hell is one-time pad encryption? It is the only method that cannot be broken for the rest of time when you use it correctly. And like I said, it is future-proof to advances in cryptanalysis, computation, and mathematics. And it has been used in practice to secure extremely sensitive information with very long shelf life. A brief history. It was discovered by Frank Miller in 1882 and implemented by Gilbert Vernon in 1919 using an electronic system for telegraphy applications. It was proven to be information theoretic secure, or abbreviation IT Secure by Claude Shannon in the 1940s. This is significant as it means that no amount of increases in computational power or advances in mathematics can break it. It is fundamentally secure. And for examples of practical use case, it was used in the Moscow-Washington hotline between their teletype machines and the ANC during apartheid for their resistance against the ruling government. Now, caveats. One-time pad will only be IT secure when the keys are truly random and have uniform distribution. And the keys cannot be reused in any way. This is an important point, as reused keys were allowed Project Venona, an American top secret project, to crack Russian communications because the Russians reused their pads. Also, the keys cannot be sent over like non-IT secure channels, or it breaks the point of one-time pads. Also, in order for your message to be uncrackable, the keys need to be as long as the message, and you can only have one copy of a very physically secured key in existence. If there are leaked copies, like if NSA breaks into your house and makes a copy, your message is not secure. And you need to destroy your keys immediately after you encrypt or decrypt a message. Also, a few more caveats. One-time pad cannot provide message authentication or provide tamper resistance. If someone messes with your ciphertext, you cannot detect that. Simple. Well, you can, but not in a strict mathematical sense. Also, it cannot prevent an untrustworthy party from leaking your secrets. Now, I'm going to skip over all the technical shit because we have limited time. So there are a few tips and tricks I would like to say. First, do not fuck up your pad generation by adding or multiplying the results when using dice to generate. That is a pitfall I fell for. It will generate non-uniform results. Also, I would recommend using formatted notebooks for pads. I recommend writing in Rain journal with universal pattern. Also, if you are dealing with users with special needs, or just for the sake of accessibility in general, I would use groupings of 2 digits instead of 5, because there are people who suffer with numerical or just regular dyslexia. Also, I would recommend using 6 D20s to generate the pads. It has the least overhead for mental effort to remember a string of digits, and also the least overhead time between looking at the numbers and copying. Also, same goes for copying pads right after you generate. So, pros and cons. As said, it is unbreakable when used correctly, and it can secure sensitive information that must stay secret for a long time. See the shelf life. But cons, it is very time consuming without automated pad generation or encryption decryption. And keys must be exchanged securely, or everything is moot. Also, the keys must be kept under strict lock and key, or someone can break in and just steal your stuff. So, discourse on OTPs. Many think it's not practical because of the key exchange problem and various snake oil implementations by slimy vendors, basically saying, oh, like, I'm going to and one-time pad encrypt a symmetric key and use that symmetric key to derive a message. No, that is not one-time pad. I would argue this is not relevant to our application because we are enforcing a correct implementation of one-time pad. So on the other side, Dirk Regiments, the author whom the Whonix wiki references a lot, says it is one of the most viable methods for securing comms in a post-Snowden world. In a post-Snowden, well, we'll move on to next slide, but in one of his blog posts, it was mentioned that it is an engineering problem instead of a cryptography problem. My personal opinion, yes, I agree. Why I agree with Dirk Regiments and the comment is because of various efforts to compromise encryption and backdoor hardware. See UK Online Safety Bill, Project Bull Run, and the potential backdoor in Marvell hardware. Also, I agree that it is an engineering problem, and I think that it is a trifecta of these specific problems. Method of securely exchanging your keys, quickly automating pad generation, and like basically not spending mental effort to decrypt and encrypt by pencil. The hardest problem by far is secure key exchange, but right now, I'm not gonna solve that for now. So, in my journey to adopt one-time pads, I decided to attack the problem of how to securely automate encryption and decryption, I came to the solution of analog computation. Why analog computers? Analog computers can significantly raise the difficulty of backdooring your computer. A lot of the existing hardware backdoors are digital, and it basically using analog can sidestep this issue. And also, analog components can be verified using simple tools such as resistors and a digital multimeter. Also, in the proposed design, any backdoor that is effective in retrieving past information or past state requires an adversary to be in physical proximity or have direct physical access to the critical chips. Now, why also turn to analog is because there are lots of generic parts on the market. We can reuse different parts with the same pinout, so it makes it a lot harder to compromise when multiple silicon vendors can provide the same part or compatible parts. And also, since those parts are widely used in appliances, we can salvage them from existing devices that are assumed to not be compromised. Also, with analog construction, it is a lot simpler to understand using online resources and cookbooks, and it allows easy user verification by looking at the schematic, by looking at the PCB, and by just probing it with multimeter. Also, since I was thinking of maybe selling this, we could do what what's the vendor? No, not Nova Customs. What NitroPad does, and ship the critical components in tamper-evident packaging, such as the comparators and operational amplifiers that do the math in analog. Also, since I'm here, I will also like some feedback on if there is demand for this, as I can optimize costs to drive. I can optimize the amount of materials I buy to drive down costs and rely on economies of scale to provide a cheap and usable model. Potential challenges to the analog computer. If there's no demand, I cannot rely on economies of scale, and the precision components are quite expensive. One resistor is $1, when other resistors are like few cents, like a fraction of a cent. Also, in order to assemble all of the components, a lot of times you need to rely on online vendors like DigiKey, Mouser, or or Farnell, because there are not a lot of brick and mortar stores that sell the necessary precision components around the world. Also, availability in third world countries might be an issue due to purchasing power, and also just not being catered to due to historical and geopolitical reasons. Also, even if we solve the issue of quickly and effortlessly encrypting or decrypting a message, we still have to solve the issue of key exchange and what was the third one? Yes, keypad generation. I will talk about these two in the open session. Also, unknown unknowns. After the project is published, governments or high-level targeting entities can come up with novel attacks against the design of this of the analog computer. And also, in the first few revisions, there might be pitfalls and flaws, such as not enough shielding or not applying low-pass filtering to prevent transmission of the previous state or critical data out from the device. And also, if you in certain countries, if they find out that you look up the schematics for this device, or you get the components that are similar to the bill of materials required for this device, they could target you because they don't like encryption. And also, I very well could be compromised by nation state level adversaries, but I have a way to deal with it. I'll talk about it later. Conclusion, OTPs are provably secure, but quite unwieldy due to key exchange issues and key storage issues. I propose that we can use analog computing to automate one aspect of using OTPs, and that is encrypting and decrypting the message, so you don't need to spend mental effort. Further research is required. I would very much like feedback from the community to help the mass adoption of one-time pads, and key exchange is a problem that we need to solve. Please do not crucify me. I did not properly cite everything in like APA, MLA, or some academic format. I through this together in 3 hours, and here are the references. I will upload the slides to the Matrix server later so you can look over the resources yourself. Yeah, that is it. Is there anything else? If not, we will move to Q&A session.